Hexagonal crystal system. By the end of this topic, you should be able to understand the key differences between a cubic crystal system and a hexagonal crystal system, to be able to draw a unit cell for the hexagonal primitive structure, and to be able to do a projection drawing for the hexagonal primitive unit cell. As within the cubic crystal system, we shall start with a 3D hexagon. As we want the unit cell, which is the repeating smallest unit that shows the full symmetry of the cell, we can take a small section of this 3D hexagon shown by the dotted lines. Taking this small section, we then get the smallest repeating unit for the hexagonal crystal system, which is shown here in bold. We can now look at how the atoms pack into the primitive hexagonal unit cell, just as we did for the cubic unit cell. The atoms pack onto the corners of the shape, just as in the cubic crystal system. There is also one atom that sits in the middle of the hexagonal primitive unit cell, and this is shown in red. This shall be explained further when we get into close packing. Now that we have the 3D unit cell structure for a hexagonal crystal system, we can now turn this into a projection drawing just as we did for a cubic crystal system. So each of the atoms on the corners of the hexagonal unit cell then sit on the corners of the rhombohedral that we can see here to the right, and these have the levels 0 and 1. And then the red atom, which sits slightly off-centre in the middle of the hexagonal unit cell, we can place this into the middle of the rhombohedral, and we label this as a half, as it fills the half level, just as seen before in a cubic crystal system.